Calculating confidence intervals is a second section of Unit 8. Therefore, constructing the confidence interval is p hat plus or minus the z, and z is associated with the z-score that is associated with confidence level you want. You want to be either 90% confident, 95, what usually we use, and then you multiply that times the square root of p hat times 1 minus the p of hat, here as well, p hat, all divided by n. And again, p hat is your sample portion, and n is your sample size. So this is the confidence interval. That is your margin of error. So you're adding and subtracting margin of your sample proportion. So as mentioned before, your confidence level adds on how confident you want to be, so 90%, 95, 99, and these are the z-scores associated with that confidence level you want to have. So your formula will change how confident you want to be, and all you do is just replacing here. So this is margin of error that you will be adding and subtracting from sample proportion to get the confidence interval. So how do we do that? Let's look at the first problem. In trying to decide how much homework to give, a teacher surveys 2 of his classes to see what % of students have after-school jobs. Out of 42 students, 18 say they have after-school jobs. And here we have to calculate the margin of error and find 95% confidence interval after that. Here, your X, your yeses is 18 because that's how many students that they do have after-school jobs. It's your X here. Now your N sample size is 42 because that's how many new students were in the 2 classes and were surveyed. P hat sample proportion is the decimal of those positive responses, which is 18 divided by the total of 42. It's 0.43. And now we're ready to find the confidence and margin of error first. Now we want to be 90%, so we have to use the z-score associated with that, which is 1.96. So z-score of 1.96 times the square root of, again, this is p hat, which is p hat, and divided by the number of people surveyed, 42. That gives us 0.1497, and let's 0.15. Now for confidence interval, we will be taking down our sample proportion and adding error. So this is a margin of error. So again, this part is margin of error, and then we are adding and subtracting it from and to our proportion, and that gives us 0.28, 0.58, or you can write it as a percentage. If you write it as a percentage, your response, or you can just leave it as the decimal. And then is it possible his students have after school job? Why not? So half is 50. We can see that 50% is within the confidence interval. So we can answer yes, because 50% is in the confidence interval. You can now try to do problem 2 and problem 3, which are very much like that first one, and check the answers with the posted notes in Canvas or when they become available to you. Now let's look at this problem. It's finding margin of error, and the National Health Organization found that between 24 and 36% of middle school students have been intoxicated. What is the margin of error for this confidence interval? So let's see what we are given here. We're given here between 24 and 36%. So we're given the confidence interval. And what do we have to figure out? What is the margin of error? So if this is confidence interval, then there was some p hat, right? The sample proportion, that a number, the margin of error, was subtracted and added to give us these numbers. So we have to now kind of think backwards. What do we need to do? So what do we have to do? It's actually the sample proportion is in the middle between these two. So what we will do, we will add these two numbers and divide them by 2 to find our sample proportion. Once we have sample proportion, we just have to ask ourselves, so how far from that sample proportion is it to 24 and how far is it to 36? It should be, of course, the same number, and that will give us our margin of error. So here you have the solution as I discussed. We're adding the two percentages. This is the lower percent of confidence interval. This is the upper. We're adding them, divide them by 2, and we get that middle number in between them. It's 30. And then we're in percentages, so it's 30%. Now we have to figure out how far from 24 and how far is from 36. So of course it's kind of easy to figure it out without even doing any math here or writing anything down. But just if in case you get tougher numbers, then you can write it. So you can, for example, take the upper percentage, 30%, and subtract that p hat from it, 30%, and it gives you 6%. So that 6% is your margin of error to this for this problem. You can now number 5, which is pretty much again the same as a practice, and check the answer in Canvas. This is a third type of problems in this section. Bigger is better for samples. We're finding pretty much what the sample size should be in order to get the desired margin of error. So in this case, it's 5%. We want to have margin of error of 5% while we are 90% confident. And our 65% is just the sample proportion, because that's the percentage of students, seniors at MHS, that drive a car to school. So again, let's just read it. Suppose that we think 65% of seniors at MHS drive a car to school. How many people would we need to sample to have a margin of error of 5% or less for a 90% confidence interval? So again, we have margin of error, we know the confidence left to have 90%, we have our p. The only thing we don't have is the n, and that's what we have to find. So as mentioned, we have margin of error of 5%, and we have to change it to a decimal. Our confidence level for 90% confidence interval is 1.645, so that's what we will be using, and our p hat sample proportion is 0.65. Now what we will be doing here is using this formula for margin of error, which we have, using this z-score. So we're going to plug this one in here, this over here, and then p hat, of course, here and here. The only thing that will be missing is our n, and that's what we will be trying to solve for. So here I plugged in 5% for margin of error, 1.645 for z, and then p hat 0.65, n is still here because that's what we're solving for. First step you should do, and again, there are different ways to solve it, but that's the one that I showed you in class, is to divide by 1.645. So first both sides get divided by that. So this will reduce, and this will be divided by 1.645. Okay, so here we divide it by 1.645. Here on the right side, 1.645 reduced. We only left with the square root. So the second step is to square both sides, meaning we're gonna raise both sides to power of 2. So 0.65 times 1 minus 0.65 is just, if you multiply 0.65 and then times that 0.35, it is just 0.2275. And then we have below what we get 0.05 divided by 1.645 is 0.0304. So just so you're not surprised where I get these two numbers from, right? Again, this is just 0.2275. And if you divide these two, they give you 0.0304. I'm not going to raise that to the power of 2 because often if you do that in other problems as well, this will become very tiny and your calculator will give you a scientific notation. And it's going to be harder for you probably to express this number and write it down. So I will just leave it as just 0.0304 to the power of 2. Now what do we do from here? If you can see the n is in the denominator, we don't want to have this fraction here. So in order to not have the fraction, we will multiply both sides by n. Okay? So multiplying both sides by n, here n reduces and this number is just multiplied by the n. And it looks like that. Now what we would do, we want that n by itself, so we're going to now divide both sides by 0.0304 squared on both sides. When we do that, that's what we end up having, and that equals to 246.7. Since we're talking about sample size, and these are people that we're going to be surveying, or individuals, we want to round up. So you round up from the number that you get, and that would be 247 people. So we need at least 247 people in our survey in order, right, if we go back to problem, in order to have the 5% margin of error at 90% confidence interval. Now you can try the other problems, number 7 and number 8, that are pretty much again the same for a practice, and check your answers with Canvas notes. One last thing is about interpreting confidence intervals. So how do we do that? It's always the same sentence you can use. Of course, you can use little variations of it, but the main idea is that when you have the confidence interval in this form, parentheses lower percent, upper percent, and you are asked to interpret it, what you write is just we are, and then either 90, 95, or 99% confident, depending what your confidence level was, based on our sample, that the true population of, and what was it in the problem, just refer to the problem to answer it in the context, is between that lower percentage and upper percentage. You can use the decimals as well, or just the percentages, and that's pretty much is that the lesson.